All right, the second type of problem we see with these insoluble salts, which they're insoluble, again, based on that gray area of not completely dissolving, but again, the context of the question has something to do with solubility. The second type of question we see is, what is the molar solubility of blank at 25 degrees Celsius? The assumption here is that I can look up the KSP. I'm at 25 degrees Celsius. That's where our KSP tables are. But now I'm looking for the solubility, which was given in the last problem to find the KSP. So this is exactly backwards. And by the way, both of these problems, we worked problems like this back in the equilibrium chapter before acids and bases. They just weren't regarding molar solubility. They were regarding other types of equations. These are specifically for insoluble salts and the vocabulary is associated with it. So for example, what if I want to know what the molar solubility of lead 2 fluoride is at 25 degrees Celsius? Again, you're going to get a lot of practice with nomenclature. The lead 2 fluoride is the lead plus 2 and the F minus. You're going to need to be able to make that formula. It's PbF2. You do get a lot of help here because if you go and look at your KSP table, all right, we will need to look up KSP. You'll find the formula there. On the KSP table, it lists compounds by cation, so there is a grouping for lead, the lead cation, and if you scroll down that list, it doesn't give you names, it gives you formulas, but you'll see the formula for PbF2, which is lead 2 fluoride. So that's a good help to recall these things. So I will have an equilibrium reaction. There's a KSP associated with it, which I look up on that table in this case because I'm at 25. Let me write their equilibrium reaction, PbF2. This is a solid in equilibrium with the Pb2 plus ion and 2 of the F minus. Watch your stoichiometry. There is an ice table associated with it. There is a KSP that I'm going to go look up. Let me go ahead and grab that. For PbF2, it's 4 times 10 to the minus 8. The KSP is unitless. I want the molar solubility. So what is it asking? It is asking for how much of that compound will dissolve. It's asking for minus X in my ice table. Over here on the right-hand side, starting with 0 of each of these, this is plus X, but notice this is plus 2X because of the stoichiometry. The M minus X, you don't even really have to carry that along because it doesn't show up in the KSP formula, but this equilibrium is X and that equilibrium amount is 2X. And so I'll set up my formula. KSP is equal to the Pb plus 2 ion concentration times the F minus squared. Look at where my 2 is. It's not 2F minus, it's the F minus concentration at equilibrium, whatever that value is, squared. Now that value happens to be 2X, and the value for the Pb plus 2 is X, but it's not 2 times F minus, it's F minus at equilibrium. And so let me plug into my values. We've seen a problem just like this before. We just have some new vocabulary. This is not a quadratic, but it is an equation with x to the third, but it is very simple to solve. Let's do a little simplifying. Notice that the 2x is in parentheses for squared, so that's 2 squared times x squared, or you end up with 4x cubed altogether. We're going to see this pattern a lot. And so 4 times 10 to the minus 8 equals 4x cubed. This is a good time to make sure on your calculator you know how to take the cube root of something. I'm going to divide by 4. 4 times 10 to the minus 8 divided by 4, then take the cube root of it. Again, make sure you know where that is or find yourself a solver online. You can use math solvers online during quizzes and exams. I get 2.15 ... times 10 to the minus 3. I'm not rounding it yet, and that is X. X is the molar solubility, so that would be the answer to this question. If the question says, what is the lead ion concentration at equilibrium, the answer would also be 2.15, and I'd probably go to one or two significant figures. If you're typing this into a problem online, just pay attention. Molarity, because the lead ion concentration is X. If it asks what is the fluoride ion concentration at equilibrium, please note that the fluoride ion concentration is 2X. So it would be times 2, and again, I'm going to round to 1 or 2 significant figures, depending on what my instructions are. 4 times 10 to the minus 3 molarity. So the stoichiometry can get pretty tricky, but you got this. You got this. This is, pay attention to the vocabulary and what it's solving for.